hard at filling in the gaps where government funding falls short. So like so many organizations and parks and refuges and green spaces, federal funding is getting less and less. And as a result, friends groups come into play to help fill the gaps. So this building was built by private philanthropic support. All of the exhibits, all of the interpretive exhibits, the internship program, the Indigo Trail Boardwalk. How many of you have been down Indigo Trail Boardwalk? So most of you, that's wonderful. They didn't know it was open on Friday, so it is open today. And they've been seeing Roseate Spoonbills down there, and they saw them this morning. So if you have time after the presentation, head on over there. It's about, just a hop, skip, and a jump from the Education Boardwalk in the pond where they've been seen. And he got some amazing photos of some Roseate Spoonbills out there. So it's a wonderful opportunity to experience wildlife on this area on a Friday, but really 7 days a week as well. So the Friends Group does that. We have land acquisition. We helped acquire the Woodring property. If many of you are from this area, that's a historic piece of property at the mouth of Tarpon Bay. It's the water opening to the refuge. We've now just engaged in another land acquisition, which is as you're exiting Wildlife Drive. It's just beyond Calusa Shores at the entrance of the sanctuary on Wolfert Road. And we're trying to acquire 5 acres there to keep, or 8.5 acres to keep from 5 homes and a dock being built there. So if anybody's interested in learning more, it's kind of a last, spur of the moment campaign where they were willing to sell, and we said, okay, we'll do it. We want to protect it and preserve it, and it expands the wildlife corridor and protects and preserves that area for the wildlife. So if anybody's interested in learning more on that, we'll be happy to fill you in. So if you're not a member, we have sunset brochures out there. I told everybody about the E-Ding on the Wing, the e-newsletter. If you've not signed up for that, it's a great little newsy newsletter. Sarah Lathrop is our associate director who started out as an intern. So it's testament to this internship program. And anybody who has children, grandchildren, nieces, nephews who are interested in the environmental sciences, we have internships in biology, education, visitor services, and in nonprofit with the society. So we have some great opportunities where they provide housing and a stipend. So it's great. It helps build their resumes, and it really gives us great help. 12 years ago, Tony Westland was here. There were 22 staff members. Today, there's 11. They're managing more land, nearly 8,000 acres, and just last year, there was nearly 1 million annual visitors here at the refuge. So 11 staff can't do that. And I know there's a lot of volunteers in here, so thank you to all of our volunteers, 282 people strong. And I think last year we just had our volunteer recognition event where I think all of the hours, it was 40,000 plus hours, I think, and it equated to 22 full-time staff positions. So it shows you how we could not do what we do here at the refuge without the volunteers and the students and the Friends Group. So if you're not members, we'd love to have you join. And then for this lecture series, a special thanks goes to our lecture series sponsors, Mike and Terry Baldwin, who have been involved for many years as volunteers and board members of the Friends Group, and Hightower Financial Advisors in Fort Myers. Jack Thomas grew up along Woodring Point and has a special love of this refuge, and they are sponsors of this as well, and there's information about Hightower out there, so special thanks to them. So Jerry has come here many times, and we thank him because this is like high season for him and his research with Roseate Spoonbills, and he says they're acting very weird this year, but we've had really weird weather too, and but he's been given some great presentations, and we're thrilled that you could come back, Jerry, so thank you. He's been the state research director for the Audubon of Florida since 2005. He serves as a member of the Florida Keys National Marine Sanctuary Advisory Council and is founding member of the Florida Oceans and Coastal Resources Council. He combines Audubon's 80-year record on spoonbill nesting patterns in the Everglades, Florida Bay with his own personal experience studying the fish on which spoonbills feed. His most recent work of banding and tracking spoonbills finally explains why it took so long for the spoonbills to recover from plume hunting and why spoonbills in Florida Bay continue to decline while most other wading birds in the Everglades region are increasing. So please join me in welcoming Jerry Lorenz.
I'll try to remember. Can you hear me? I'll drop it, just yell at me, that'll work. Go ahead, hit the lights, thank you.
Is that good, or do you want it darker? We'll
Can everybody see okay?
Yes.
Okay, then that's fine. Thanks for the introduction and thanks for having me again. I always like coming back to this area. It's just beautiful. So as Bertie was saying, is that I'm not an ornithologist. I'm a marine biologist, and I moved to Florida to actually study fishes. Not that there's anything wrong with being an ornithologist, but when I talk to birding groups working for Audubon, you know, you kind of run into a conflict frequently. And I like to point out all the time that, oh, by the way, if you were here last year to see this presentation, you're going to see the same presentation. There is some new stuff at the end. So I like to tell people that there are more fish in the world than there are all other vertebrate species combined. So more fish than there are amphibians, reptiles, birds, and mammals. If you put them all together, you still have more fish. And with that kind of diversity, you get a lot of different things. And I try to convince my colleagues in the bird world of this. I point out things like when you look at the size of the predators, for example, there's a marshal eagle sitting on a small deer, and that's quite the kill. But that's a great white shark. And people don't go outside and say, I'm not going out in the air today because there's an eagle, but they might not get in the water. Sheer size, largest bird in the world, top hat guy over here is riding an ostrich, and those two probably don't even weigh as much as that fin on a whale shark. Just personality, I got a parrotfish and a parrot that's a Senegal parrot. On this one I kind of have to go with the parrot. This is a friend of mine's bird, so I like him. And just color. You got the peacock, and that is a mandarin fish. And just spectacular colors. So when I moved to Tavernier and started working for Audubon, I thought, well, finally the world's coming around to my way of thinking. Audubon's hiring a fish guy, and there it was. And so I felt real proud of myself. I was young and naive. And what I got was a lot of pushback and a lot of conversations with my colleagues. And they basically said to me, one of them at a party said, look, stop talking about fish. There are 3 types of fish: bait, food, and other. So, well, I came up with my own nomenclature for birds then. And this is Terry Lorenz's ornithological nomenclature. If it flies, it's an eagle. If it's sitting on the ground, it's a chicken. If it's sitting on the water, it's a duck. If it's underwater, it's a penguin. And if it's in a tree, it's a crow. This did not go over well. Did not go over well at all. So my boss at the time, Sandy Sprunk, Sandy worked on, he was actually vice president in charge of science for National Audubon Society. And Sandy dragged me into his office and said, look, you got to quit talking about fish all the time. We're a bird organization. I said, Sandy, I don't know anything about birds. And he says, well, you're going to start. And so he said, get in the boat, go out to the western side of Florida Bay, go out to Sandy Key. And when you get to Sandy Key, anchor up on the west side of the island, get out of the boat, walk to the east side of the island. You're going to see some spoonbills there. Start counting them. Like, okay, I know where Sandy Key is, but I still don't know where a spoonbill is. And he about smacked me at that point. He says, look, just go over there, walk through that island, look for the bird with long legs, pink, and a funny bill. Pink, long legs, funny bill. So I get out there, start walking across the island, covered in mosquitoes. It's a nasty place. Well, actually, Sandy Key is beautiful, but when you walk through the swamps, it's not so beautiful. And sweat pour off me. And I'm saying to myself, pink, long legs, funny bill. Pink, long legs, funny bill. So I get to the other side of the island. So I started studying nesting of spoonbills. So, in all actuality, was hired to study the diet of roseate spoonbills. And I was thrilled with it. My job was, we were seeing a decline in spoonbills, and my job was to figure out why. We suspected it was dietary related. We suspected that they weren't getting enough food, and that's why their numbers were going down. So my talk today is basically going to be the bad, the good, and the ugly. Most of it's bad. I do have some good news at the end, so stay tuned. And then I'll discuss this past year, which was pretty ugly. What we have in Florida, and most of you probably already know this is a satellite image from 1492, and it shows the way the Everglades used to work. Water would flow south, not to the east, not to the west, not towards you guys, flow south and end up, most of the water fresh water would end up here, or here, or here in Florida Bay. And this is what we've done to it in the last 100 years, put in all these dikes, so we got all this compartmentalization. Each one of these is managed differently, separately. They have their own criteria, and so it doesn't matter what the adjacent one does. And it's really made a mess of things. And of course, the further you go downstream, the worse it gets. It just gets compounded as each one of these things disrupts the flow. It just gets more and more compounded. So Florida Bay being at the tail end is kind of telling us what the Everglades is doing all the way up. And so here is a blow up of what I'm going to be talking about most of the day. This is northeastern Florida Bay. Up here is that main Shark River Slough, just on the edge. But this is the main flowway into Florida Bay. This is Taylor Slough. So water flows from basically across this area, through these upland areas, and finally into Florida Bay. It's estimated that we get about 1/4 to 1/3 of the fresh water that we did historically. It comes in at the wrong times and at the wrong places, as I'll show you. An intro to Florida Bay is it's a shallow subtropical estuary. It extends about 850 square miles, so it's very large. It's covered in grassy mud banks and basins, and it's divided up by these mud banks into little, what we call lakes or ponds, but they're large. But that disrupts kind of the way the water interchanges between the two places. It's home to one of the most species-rich assemblages of fish-eating birds in the world. It's world-class recreational fishing. The things that people come to the Keys to fish for in the backcountry are bonefish, redfish, snook tarpon, and myriad other species. Sea trout being sea trout, and snapper being involved. And then it is also the nursery ground for our shrimp, stone crab, and lobster fisheries, which are critical to our economy. So here's where the problem starts, is that when we diverted all that water, what this is again, this is northeastern Florida Bay, here's US 1, and here's that flowway of Taylor Slough. And what these green lines represent is the area of mangrove dominance, mangrove being a salt-tolerant tree. And so in 1948, the mangrove really just started right on the edge of the bay. And then we started to see it move inland by 1967, 1977, 1994, and it continues to expand inland. And this has been scientifically demonstrated to be a result of lack of freshwater flow rather than sea level rise. It's a combination of both, actually, but it's going a lot faster than sea level rise can account for, indicating that the lack of freshwater flows allowing these mangroves to move inland. So things started to get ugly as soon as I was hired. In 1989 is when I started working in Florida Bay, and by the end of 1989, we had massive seagrass die-off in Florida Bay. This is the areas that ultimately died. So again, remember the size of this bay. These are huge areas, many, many, many square miles, if not hundreds, maybe even thousands. So all of that seagrass died between 1989 and 1991. And it ended up with started these series of huge algal blooms. The most recent one was in 2007. And on August 18th, I literally went out in the boat and traced what the spatial extent of that seagrass, or the algal bloom was. And it literally extended all the way from the Everglades out to the reef tract. And that's bad news. This is a picture of Tennessee Reef from the air a couple of days after I did that survey. And this just looks like a reef line, but when you look at it much more closely, you can just see this algal bloom extending out across Tennessee Reef. And of course, this does damage to the reefs. This current slide is not the result of that, but it shows an example of what things look like at Canaries Reef in 1960, and then what they look like after the 1989 event. And so we're losing our corals as well. So it's not restricted to these things. This is an article that I published a couple years ago, and it just details the decline of the vertebrates in Florida Bay. And as you can clearly read from this slide, is that there's a lot. This is just a list of the species I documented that were in decline, and then the justification of what happened to them. But essentially, what we saw are declines in reptiles, the endangered American crocodile, the mangrove terrapin, mammals, bottlenose dolphin, and manatee use declined very rapidly, and then the birds. We got 5 species of birds that responded very poorly. Great white heron, osprey, brown pelican, bald eagle. Well, actually, we have 6. The reddish egret and the spoonbill are both on this list as well. Reddish egret's just a little bit harder to document. We also saw declines, and this is where I come in what are the prey-based fishes. These are the things that everything in the Everglades eats. Okay, this is the bottom. Predatory birds, everything that I just showed you at one point or other in their life cycle ends up eating these little fish, and especially the spoonbills. And we very well documented the declines in this prey base. And also our game fish. I just put up a snook and a redfish here, but sea trout and numerous other game fish also went on the decline. Speaking of snook, that's what I really wanted to study when I came south from Kentucky. So here's a guy just caught a very nice snook, and you can see one of my little pink buddies back here in the background. And if you look at the fish, when you catch it, tends to regurgitate what it's eaten most recently. And this is exactly what spoonbills eat. So they're feeding in the same place and feeding on the same things. Now, the problem with studying snook is you can't follow them around. They're really hard to, you can't like identify one and say, I'm going to come back. Spoonbills you can. You can go to their nest, you can mark their nest, you know who the parents are, you know if they raised their young. And so it becomes much easier to follow snook around, or spoonbills around, and so I like to refer to this as a pink snook. Great indicator species because of that. It tells us exactly what's going on in the rest of the environment. A little bit of background in spoonbills. This is a skeletal bill of a spoonbill, and it's actually taken on that nice background is my 1983 Toyota Corolla. But you can see all these holes, and that's where the nerve endings come through. It makes the bird light, but it also makes this bill super, super sensitive. Much more sensitive than your fingers or your lips. And that's important because the spoonbill feeds by tactile location. It doesn't strike at what it feeds on, it feels for it. So it gets in the water and it moves it. So I'm sure you guys have seen this. It walks through the water kind of drunkenly and swishes its bill around, slightly open like that. And when it encounters a prey item, like this bird is doing, the head immediately snaps back and I swallow it and then just keep going. I like to call these guys, they're basically little vacuum cleaners. And so they just go out where there's high densities of fish and they suck them up. Very efficient, more efficient than the visual predators when conditions are right. When conditions aren't right, they don't do nearly as well. So what they feed on is, this is a sheep's head minnow. You can see it's about 5 centimeters, about 2 inches, and about the same size as this sailfin molly. In Florida Bay, these 2 fish are the most common fish we collect, and they make up about, depending on which bird you're looking at, about 60 to 80% of the spoonbill's diet. I get asked all the time, because flamingos eat shrimp and they're pink, and if they don't get shrimp, they turn gray. Is that true of spoonbills? It is not. Spoonbills will consume shrimp. They do not have to. Their diet's highly varied. They eat insects, they eat snails, they eat shrimp, but mostly that bill is designed to catch fish. They are fish eaters, and their color doesn't change if they don't get any shrimp. So in the Everglades, the fish during the wet season, when the water's high, they spread out, and then they make more of themselves. They go through multiple generations. There's one fish out there that can literally go from when it is released from its mother, within 6 to 8 weeks, it is sexually active. So you can go through multiple generations of these fish over the course of a 6 to 8 month wet season. And of course, you get exponential increases in these fish. You get a whole lot of them. But then during the dry season, what happens is the water levels start to drop, and the fish have to find a refuge. They have to go someplace. And what they do is just when the water level gets down to about 13 centimeters, about 5 inches, they head for deeper water. And then the water concentrates them even further. And this is the situation that spoonbills are designed for. When they got these high concentrations, they can go out. I like to make the analogy that if you drop a bowl of Cheerios on the floor of your kitchen, one of the things you might do is just go grab your vacuum cleaner and suck it up. It's very efficient. Now spread that bowl of Cheerios throughout your 8,000 square foot house, and the vacuum doesn't seem like a very good idea. So this is just an example of what that looks like when they're concentrated. This is a picture of my hand. I'm just holding the camera. This was taken in 1990. So sorry about the graininess. These are all just fish, and this is right where I'm standing next to about a dozen spoonbills. If I lift my hand out of the water, I can collect those fish. Now, my hand is not designed to catch fish. Think about what it would be if I were designed. And the reason they need this is because they lay 3 eggs in a nest. They nest in Florida Bay. They used to nest in November. It gets later and later every year. I'll explain why in a minute. But the eggs are about the size of a chicken egg. And so when the chick hatches, this chick just hatched, still blind, they're the size of a chicken egg. And within about 6 weeks, they're the size of the adult. So you got 3 chicks growing from the size of a chicken to the size of the adult in 6 to 8 weeks. That requires a lot of food, and let me tell you, everything that goes in that mouth doesn't stay in that bird. I know this for a fact. So what happened to spoonbills? Well, initially they were quite abundant. We don't have any numbers prior to the plume hunting era, but they were highly prized during the period when feathers became the trend on ladies' hats. And I've read many accounts that say spoonbills were not targeted because their feathers fade, and they do not. I have feathers on my desk that I collected in 1996 from a dead spoonbill. They are still pink. I have seen pictures of museum specimens that were shot in 1890, and in 2015, they're still pink. If you look at some of the scientific literature, there's one, I can't remember the gentleman's name, is written in, I believe, the 1890s, and it said how much everything was worth. It just said, well, this bird's worth this, this bird's worth that. The most expensive thing on that list was 50 cents a pelt for a great egret. And then right below that was $5 a piece for roseate spoonbills. So the egrets were worth more than their weight in gold, and the pink feathers of a spoonbill was worth 10 times that amount. So what happened? Spoonbills were hunted basically to extinction in Florida and in Texas. There were some that would come back. Basically, all the evidence indicated that some would come over from Cuba, but they wouldn't nest. Everything else was nesting. Everything else was recovering. And then in 1935, an Audubon warden discovered 5 nests on a small key in Florida Bay. And from that point on, we see this recovery all the way up. The yellow is the total in Florida Bay. The red is the northeastern part of the bay, which is where the majority of birds nested during most of this period. So then all of a sudden, you get up to this 1,250 nests, and it drops down, kind of recovers, drops down, and then just plummets. And so the question is why? And that's why I was hired, is we knew this was going on, we just couldn't convince anybody why. We kind of suspected it was the food resources. So the first person to start working on spoonbills in Florida Bay, this is Robert Porter Allen. He's not very famous, and he should be. He basically reinvented the way we do bird ecology. He spent many years living with spoonbills. He wrote books about flamingos. He probably single-handedly saved the whooping crane. The reason Florida Bay is part of Everglades National Park is because of Bob Allen. There are 3 keys in Florida Bay named after Bob Allen. Bob Allen Keys. And so he's an important figure. And if you read his history, he is a very unique man. When Bob was studying spoonbills, most of the spoonbills nested along the mainline key. So this is Key Largo Plantation, and you go down to the Matacumbis. And the red dots represent where the birds were nesting when Bob was alive. The blue rings represent the average flight distance a spoonbill will go from its nest. It's actually average plus 1 standard deviation. But basically all the birds will stay within this radius. If they have to fly further than that, they're not finding their food, and chicks are pretty well doomed. But you'll notice that all of these rings for all of these colonies overlap right here, and that's the separation between Key Largo and Plantation Key. Now, at the time in the 50s and 60s, the southeastern region, it went up and then it came back down. The largest single colony was a island called Cowpens Key, and it went up to about 60 nests, plateaued, and then plummeted. So the question becomes why? Well, just to give you an orientation, here's Key Largo, Plantation Key. This is Cowpens Key. It's about not even a mile offshore. This is the creek that runs through there. Bob Allen's house was right about there. He had a boat that he kept here. He would come out and he would sit at Cowpens Key and circle it at dusk, count the birds, which way they were flying, document all that, and then spend the night there and do the same thing first thing in the morning. Unfortunately, Bob died in 1963. Very suddenly from a heart attack, and his notebooks just sat in our office in Tavernier. People would pick them up and look at them, but I found them incredibly interesting. And so I documented, I just went in and took all of his sightings, what direction the birds were heading in for the 5 years that I had that information. And what I discovered is his slides represent, at the center here is Cowpens Key. And this represents the directions the birds were flying in to get food away from the nest. And the intensity of the color indicates the percentage. And we're talking, he went out there every night during nesting season, so the total number of these flights was in the thousands for each year. So you can see in 1957 and 58, the birds were flying primarily to the east and the southeast. Fully about 80% of the flights were in that direction. They were ignoring all the other compass headings. Less than 10% in these two, and basically nothing in any other direction. So if you look at Cowpens Key, and I've laid these aerial photographs, this is 1945, this is 1964, and I had to lay them over so that this is north, just to fit them both on a slide. And again, here is Cowpens Key. So to the east and to the southeast is where they're flying, and there were these two huge wetlands on Plantation Key and South Key Largo. Well, in 1958, this huge wetland turned into this subdivision. My office happens to be right there. And so that wetland was completely filled and destroyed. And in 1959, you can see the birds changed their direction. 60% of the flights to the east, now they're flying off in a couple of different directions. In 1959, that wetland right there was turned into these subdivisions, and the birds quit flying in directed flights. And by 1963, they're going off in every direction trying to find food. And the birds started failing, and the end result was that they abandoned Cowpens Key. A little bit more information on this is that prior to that development period, again, it's the yellow that we're looking at here. This is the number of chicks per nest, and they were producing 2 1/4 chicks on average. So they laid 3 eggs, and every nest would raise 2, and then every third or fourth one would raise 3. After that, it dropped down to 0.25. So now it took 4 nests to raise 1 chick, rather than 4 nests raising 10 or 11 or 12 chicks. And this leads us to the conclusion that food resources, where they go to get their food, are what determines whether spoonbills will be able to raise their young or not. It also suggests that they'll relocate. They don't relocate very far, but in this case, where they ended up going was to this northeastern part of Florida Bay. Same setup here, red dots are colonies. These rings represent flight distance, and all of them end up overlapping here. And we documented by tagging some of these birds with VHF radios and then going out in a plane where they were going. And obviously, they were flying to this southern Everglades region to get their food to raise their young. So in the northeastern part of the bay, this is where I divide this up into 3 sections. So this first section, from 1950 to about the mid-1960s, there were a good number of birds nesting in that portion of the bay. We had some down years where it was only 10%. We only had about 200 birds in the nest at this, or 200 birds in the bay at this time. But some years of as much as 40%. And the way the Everglades looked at that time was it was functional. Basically, you had the main Shark River Slough dumping water in your neck of the woods, or south actually. And then you still had this area where water would flow across the Rocky Glades into the headwaters and ultimately into Florida Bay. So those were the 2 main exits for the Everglade. And that was functioning just fine. In the second period, what we have is they put in a canal that really affected Florida Bay in 1960. And so it was finished in 1963. So at that point, about 50 to 70% of the nests were in that northeastern part of the bay. And remember, the nest numbers, total nest numbers are going up at this point in time. And the change there was all of this part of the Everglades, these canals were built and it drained this area, turned it into urban areas in gray and agricultural lands in orange. But it also drained the Everglades. And so a lot of the water would continue down this canal and end up in this region down here instead of going through Taylor Slough. This was not that big of a problem. The real big problem came in 1982 when all those canals received pumps. So you got major pumps instead of just gravity feed canals that drain the area. Now you are physically pushing water where it doesn't want to go. And that was always away from that farmland, which meant always away from the Everglades. Here's where those pumps were located, the green dots. This is a picture of one of those pumps. That's the 331 pump. It can move 1,250 cubic feet of water per second. So it can fill a swimming pool in about a second. This is what the canal system looked like prior to 1980. This is how big it was after 1984. So they not only just put in these pumps, they made the canal system about, the volume of it, probably about 10 times bigger. So now what happens is that the water, instead of flowing through Taylor Slough, which is in green, which is where it's supposed to go, and then it would reside in these basins. So the water wouldn't trickle out of the bay, it'd kind of be stored there. Now the water gets sucked into this canal, pushed south. There's a plug right here that keeps it from going into Biscayne Bay. And so the water flows along US 1 and ends up just bypassing Florida Bay. And the amount of water, like I said, is about a quarter to a third of what it was prior to any of this happening. In those 3 periods, what we have are the water levels are on, this is just in Taylor Slough. And so we see this, I told you about the wet and dry season, the importance of it. Wet means more fish, dry means concentrations. So in that first period, when we just had the Everglades, what we had in Taylor Slough was a change of about 1 meter, 3 feet, in wet season to dry season. The second period, it goes, this is the pink, we've dropped about a 1/2 meter, so it's not as wet, but we still get it dry. Then with period 3, when the pumps came on, we got the big canals, it flatlined. So there's very little difference now between wet season and dry season, and the importance of that is quite apparent when you look at the success rate of spoonbills. Is during period 1 in Northeast, they were producing 2 chicks per nest. During that second period, just canals, 1.4, which is still a sustainable population. After that, 0.6. And that is not. Spoonbills, to functionally grow as a population, they have to produce on average 1 chick per year. And they do that easily in a good environment. They're just not doing it here. And then this other section of this is the percent of years successful. They were always successful in that first year, or the first period. Second period, they were successful in about 7 out of 10 years. In the third period, they were successful in about 4 out of 10 years. So this is not a sustainable population. So I don't know why that slide's there. I'm gonna start talking about fish. And the reason I put this slide in is to show you that when I started this job, I had hair. So, I invented this contraption to sample fish in the habitats that spoonbills feed in. And it's just a drop net that surrounds a dwarf mangrove. The birds feed around these dwarf mangrove trees. And what we were trying to do is figure out how we quantify and change, just observe. When the Everglades flow changes, what happens to the fish? And so we've been doing this now for 26 years. And then we catch the fish inside the net, and that gives us some idea of the productivity of these wetlands where these birds are feeding. And what we found is that when you change this delivery system, you get a real change in salinity. So it fluctuates up and down. This is just the salt content of water. So you get these fluctuations from freshwater to marine, back and forth, very rapidly, that did not exist prior to this canal system. And what that does is, basically, the plants that grow in those habitats require a certain salt content to survive. And so you might have freshwater species growing, and then the salinity goes up, and then you have marine species start to grow, and then it goes back down. And so you don't ever have the standing stock of the plants. Without plants, you don't have any fish. Basically, you take away their home, you take away their food resources. Without any fish, spoonbills go away or die. And I've shown you that the salinity indeed was changing where these birds are feeding. So when I looked at this, and this is a little bit more complex, but basically all this says is that when you have fresh water, you have a lot more fish. And then as you increase the salinity, the increase goes this way or this way. As you increase salinity, the number of fish goes down. This is true of both the fish number and the biomass, so basically the weight of the fish. And it declines pretty rapidly as soon as you start adding salt content. The other thing we looked at was this 13 centimeter. We documented that indeed the fish, nobody knew when these fish would start to concentrate. Our data strongly indicates, and I published that it's about 13 centimeters they start concentrating. So this is an aerial photograph of where we sample. This is where the spoonbills feed in this center creek. These are those wetlands that dry out during the dry season. They're wet during the wet season, dry during the dry season, and the fish end up moving in here to where the birds get them, and so do we. And just to prove that, these are all spoonbills nesting. One of my nets is right there, another one is right there. These places that we sample fish, we selected because spoonbills feed there when they're on nests. And again, this one's a little complicated, takes a second to figure out, but what I've done is I've taken years that spoonbills were successful, so years where they produced more than one chick per nest. Failed is less than one chick per nest. This is the water level at 4 of our sampling stations where we collect those fish and where spoonbills feed. And you'll notice that successful years, it was always below 13 centimeters. In failed years, it was always above 13 centimeters. This is the fish. And the fish abundance was much, much higher because of that concentration effect, because the water's low, than during when water is high and they're spread out. And so this disruption would dump water out of season. So you turn on the pump, you get rainfall during the dry season, it'd fall in the urban areas, the farms, they would get angry, the water manager would push the water south, and it would flood the foraging grounds of spoonbills. So just an example of that, this is 1992-93. You see water levels are coming down. This yellow line is right at the level where fish become concentrated. This beginning at when spoonbills hatched, this when they would have left the natal island. And you can see the birds are really good at predicting when they should start nesting, because when these chicks hatch, that water level was right at that concentration point. So perfect conditions, and they're real good at predicting it. But then you turn on the pumps. We get some rainfall, turn on the pumps, water level goes up, water level goes up, water level goes up. This completely failed. During 1992-93, we had no successful nests in northeastern Florida Bay. All of the nests failed with the young dying in the nest. This paints an ugly picture, but this is what it looks like I took this picture at a colony that was failing. These are spoonbills that spoonbills nest over water typically. The adults go looking for food, they can't find it because the water level is too high. Second one goes out, leaves the chicks alone, keeps looking for food. They won't come back if they don't have food. They keep looking for food. The young get cold or hot or whatever, they fall out of the nest, they fall in the water, and they are dead. I have a much more gruesome photo if anybody cares to see it. I don't recommend it. There were 150 nests at this colony at this time. That's 450 chicks. About 5 survived, and there was a rack line of 450 spoonbill chicks along the bank under the nests, and it was pretty ugly. Okay, I'm not a heartless bastard. I rescued those 2 birds, and they were raised by the Wild Bird Center in Tavernier, and they were released, and I hope they're still doing fine. But all of this was used to add up to ecological indicators. I published a paper that said, and documented everything I just told you. It said, this is why spoonbills are really good to tell us what's going on with the Everglades, and if you're going to try and repair the Everglades, you might want to pay attention to spoonbills because they'll tell you whether you're doing it right or wrong. Excuse me. One of the things we started to do in 1995, 96, 97 is we started putting bands on these birds so that people could identify them. And if you reported a band to me, I really appreciate it. They do spend a lot of time here at Dane Darling. We get a lot of research from here. Really appreciate that. And we also put satellite transmitters on 20 birds. These satellite transmitters cost about $5,000 each. There's a little solar panel, there's a battery, there's a VHF radio, VHF antenna, a GPS unit, a transmitter to a satellite, and then it all gets beamed back to me, and it tells me where these birds are going. So we put 20 of those out, and what we found is that spoonbills don't move around at all. My hypothesis was that they would move from Florida Bay to Tampa Bay, nest in Tampa Bay, move from Tampa Bay to Indian River Lagoon, nest there, and then come back. And we all thought because they left Florida Bay, they were going someplace else. And what we found was that, no, they don't do that. This is preliminary data, but it just shows that birds that were banded, when they came into adulthood, they would return. The pink and red are all within several miles. The pink is birds that returned exactly to where they were hatched to nest. These are all varying degrees, next door, within a mile, within a couple miles. So birds hatched in Florida Bay would come back to Florida Bay and nest. Very rarely did they go someplace else. Those are the 2 blue ones. So just to cut it short, what our conclusions were based on our banding and tracking data is that they're long-lived. They lived to be about 25 years. We actually captured a bird that was 17 years old. It had been banded previously. We are now seeing, we are getting resites currently regularly of 11-year-old birds. We still have that going on today. The nesting in Florida Bay was very low, as we knew. It was less than 6 chicks per nest, less than 4 out of 10 years, and the banding suggests even much lower than that survival. And they exhibit a high degree of nesting fidelity, so they come back to where they were hatched. The implications of the birds hatched prior to 1984, when that canal system went in, are dead. The low nesting success suggests that very few recruits, so we're not getting any adults, and this likely explains the declining numbers in Florida Bay. So one more, well, I got quite a few points to go, but this is Florida Bay. And you can see the total numbers in the bay go down. Spoonbills started nesting again in Tampa Bay for the first time in 1976-77, and you can see the numbers going up. This only goes to 2006. This has flip-flop. Florida Bay is now down here. Tampa Bay is now up here. Now, this is Tampa Bay. This right here is the Richard T. Paul Alpha 5 Bank Bird Sanctuary. About 90% of the nests in Tampa Bay are on these 2 islands. It looks like 1 island, but it's 2. And what you see surrounding that island is a chemical plant, MacDill Air Force Base, urban sprawl, It's just in the middle of an urban environment. The main colony in Florida Bay up until a couple years ago was right here. This is Turnkey. Turnkey is surrounded by a national park. The only development you'll see in this picture is Turkey Point Nuclear Power Plant and the houses on the Keys. So it is in what we call a national park, supposed to be one of the most pristine environments in the world, and the Spoonbills do better in Tampa Bay. What this means for our economy is that this is what we sell in the Florida Keys, this is what you sell here. And it's the same situation here. The Everglades doesn't work, your estuary doesn't work. Your estuary doesn't work, you can't sell your environment. So you don't get to go fishing because the fish are all dead. We sell key deer, coral reefs, our corals are in horrid shape. And so this comes back to the economy. It's just not, you just can't sell stuff. And the other thing we found is this was a study done by the Everglades Foundation. It found that for every dollar invested in restoring the Everglades resulted in a 4-to-1 return on investment. This is just a graph of where, if you invest money, this is the return that we get on it. So we're a lot better off investing in Everglades restoration than not doing it. Just a little bit about Florida Bay, the economy. The annual user value in the National Marine Sanctuary, which is not the national park, but adjacent to it, was $660 million a year. And this was 2002. It is, without it, we have this $59 million a year shrimp fishery that is now dead. The stone crab fishery is still doing okay, but not great. And then $40 million a year spiny lobster. 90% of the takes of spiny lobster in the state of Florida are in the Florida Keys, and we are dependent on Florida Bay for that. So, I've given you the bad. Now here's some good, anyway, is that what we have here is the number of years. This is kind of a mixed up data set. This is the number of chicks per attempt for the years from 1982 to 2005. The red striped ones are ones that we know that the birds failed, but we don't have a numerical value for. The X's are years we do not have data for. The green are years that they were successful, greater than 1 chick per nest. And the red ones are years that they failed, less than 1 chick per nest. So you see there's this group of 4 or 5 years right here, and then this group of 2. What happened is we had a massive drought. And because you have low water during a drought, it doesn't screw up so bad. The spoonbills have something to eat. They're fish concentrated, they don't spread out. And the year after a drought's always good, and we don't quite understand that, but I just think it's that if you don't have water in these years, you can't mismanage it in the next year. So, and that's a drought year, that's the year after a drought. Well, eventually, water managers, there was a sea change, there really was, is that water managers are really, really concerned about the environment, which they weren't 30 years ago. You know, it was flood control and it was water supply. Everything else, who cares? Now they really do have to care about it. And so, over the course of the 90s and the 2000s, really there was this need to know, what can we do about it? Because we're going to invest all this money in Everglades restoration, there's a recognition it needs to be fixed. One of the things that happened is my colleagues and I, people started listening to us. And we started reporting. In 2005, I was getting a phone call from one of the engineers of the South Florida Water Management District once a week, and he would say things like, Jerry, if I open this structure, you know, what's going to happen? And I would say, well, my birds aren't on nests, so it won't hurt anything. And so they do it. But then he'd call me back in 3 weeks and say, you know, we want to open that structure again. I said, well, my birds really need that food. He says, well, how about we only open it a little bit? And so there was this discussion. And that continues on. That was institutionalized, and now we have a weekly call where my colleagues, not just in birds, but all the animals, we get together on this weekly call, and then we send recommendations to how the operations should go. And the end result was we got 7 out of 8 years with spoonbills being successful. And the 1 year that they did poorly was a drought year. And The reason they did poorly is because if anybody was here in 2010, you remember it got really, really cold that January, and the birds didn't do so well surviving that. So, here we got coming down, coming down, coming down. Oh, look, it might be going back up. So the other thing we discovered is that there's this little place called Madeira Hammock, just north of Florida Bay. We sample fish right here. And Madeira Hammock was a colony that was large and very active from the 1930s to about probably about the 1960s when the canal system went in. And then there were a couple of years where you get the colony to form, and then there'd be a 5 or 6 year gap, and then it would form 5 or 6 year gap. Then by 1982, it just stopped. Okay, so there were no, suddenly in 2010, one of my colleagues that did flights over there says, hey, that colony's active again. And so we went out there and took a look at it. We didn't do it in 2010 or 2011, but we did it in 2013 and 14, and lo and behold, one of my banded babies is nesting there. So they moved further inland. And this nesting colony was gigantic. It's the largest spoonbill nesting colony in the Everglades at this point. And so these two numbers with the drop down, we don't really know because we didn't check the colony, but clearly we're back up to about 400 nests if you include that colony. And so what are we trying to do? We're trying to restore the Everglades, quit this dumping the water to you and to the Indian River Lagoon and force it south where it goes, where it's supposed to go. And part of that, and I'm not going to describe this is just a project that went online in 2012, and this is that C-111 canal that's caused all the damage. Florida Bay is right here, and our research shows that this project works positively when there is water. It doesn't work very well in a drought because it doesn't supply new water, but it does put the water that's supposed to go to Florida Bay in the right place at the right time. We still only get about a third of what we're supposed to, but at least it's not willy-nilly. Now the ugly. This is what happened this past year, is that we had, again, this is salinity in Florida Bay, and the pink means that it is about 1.5 times that of the ocean. Okay, when you have that high salt content, ugly things are going to happen, and did. That is the area in central Florida Bay where the seagrass just collapsed. You can see as far as the eye can see, dead seagrass. And so we're back to exactly what happened in 1989. And that was simply because we had a very severe drought and we don't have Everglades restoration in place, so we couldn't supplement the water. And Florida Bay is now going through another massive seagrass die-off. The last thing is sea level rise. And this is the mean sea level, mean low water at Key West beginning in 1913 to 2015. And it is going up. And people look at it and say, well, it's a stable line, it's not doing anything different. Well, if you look at the last 15 years, it is going up at an exponential rate. We have had 4 inches of sea level rise in Florida Bay consistently since the year 2000. That's 4 inches. That's a foot in the next 30 years. And it has a dramatic effect on that environment. Just an example, and it's really affecting the spoonbills. We just don't get those dry downs anymore. So this is just the cover of a symposium account that was done in 1996. The ecological assessment of the 1994-95 high water conditions. 1994-95 was the last time we had a major El Nino event. People were screaming about how much fresh water there was in the Everglades as a result of that rain. Nobody could believe how high the water was, and it got about 60 of us scientists together to sit down for 3 days and describe what damage was done by this massive high water event in 1994-95. Okay, here's the mean water level at one of our sites from 1986 to 2012. That's the green. Yellow, 1994-95. This is how bad it got. This was awful. And the last 3 years ago and 2 years ago, look how high the water is. But we are now in a situation where what was a disaster in 94, 95 happens every year. And it's happened again this year. So I'll leave you with the ugly, unfortunately, but that is where we are. The salinity this year, we do not have any spoonbills nesting. We had probably about 30 nest attempts. That major colony that I just pointed out, we have a report as of last week that there are birds there. We don't know how many. Actually, one of my guys is out flying in a helicopter today. He's supposed to go check on it. But if you ask on our weekly phone call that I described, every single person that deals with wildlife in the Everglades is sitting there going, give it up. This year is going to be garbage. It just got too much rainfall, too much out of season rainfall. Not supposed to be there in the dry season. There are literally no nesting birds in the Everglades this year. And that's just got to do with the El Nino event. Well, we can anticipate with climate change that things could get worse. We really don't know that. What we do know is that the sea is coming to take our islands. So, sorry about the bad news. I'd be happy to answer any questions if you have.
A few weeks ago, we heard an archaeologist talking about